We have to deal with a small concept here. So you can find full of mass. Only R. Okay. We have to find the value of this. Okay. First try to understand what is this symbol is meant for. For example, let me take summation x. X is equal to 1 to 10. What this means, for x you have to substitute 1. So this x will take the value 1. When you write 1 here and 10 here, you have to consider all the values 1, 2, 3 up to 10. So it's 1 plus 2 plus up to 10. In case if I have summation x is equal to 1 to 10 x square, what will happen? 1 square. So you know, right? Okay. The same like here, we have r is equal to 1 to 10. We have to apply this r value 1 and 2 and so on for this term, r into rpr. Okay. Actually, before exactly substituting this value, I have to take this one alone. But I'm not going to take this one alone here. Instead, I'm going to take r plus 1, the whole factorial minus r factorial. Already we have done all these things in problems. Remember, we were working for 16 books have to be placed in a shelf. You remember this problem? 16 books are to be arranged in a shelf. And you'll get the answer as 14 into 15 factorial. Somewhat like that type of a problem is this. So let me take r plus 1 factorial minus r factorial first. Yes, tell me, what is r plus 1 factorial? We know this concept. If we have 5 factorial, I shall write this as 5 into 4 factorial. You remember? Likewise, r plus 1 factorial. Please check whether this is right. R plus 1, okay, into r factorial. Shall I write it this way? 5 factorial is written as 5 into 1 less to that, 4. See, what is this one? 5 into, what is this 4? How you got this 4 factorial? 5 minus 1 factorial. Likewise, I have r plus 1 factorial. This is the first term, r plus 1, okay, into, for this one, 5 minus 1, r plus 1 minus 1 factorial. Am I right? Cancel. We'll get r plus 1 factorial into r factorial. Sorry, r plus 1 into r factorial. Is it okay? Yes, now. So, I'm writing this step as r plus 1 into r factorial minus r factorial. Okay. Yes, tell me. R factorial is common. Shall I take r factorial outside? So, what is left out? Here, r plus 1 is left out. Minus, so minus. If you have r factorial is nothing but r factorial into 1. So, I have 1 here. Plus 1 and minus 1 will get cancelled. So, this is nothing but r into r factorial. So, which is nothing but r into, what is r factorial? You remember n is n factorial, right? Likewise, rpr will be r factorial. So, this is rpr. Now, please check this term and this term. It's the same. So, now come here. So, shall I write this as summation r is equal to 1 to 10. This instead of writing r into rpr, shall I write this term directly here? Okay. Yes. R plus 1 factorial minus r factorial. Yes, I can substitute. We refer this point star here. Okay. Now, let me substitute r is equal to 1, r is equal to 2, up to 10. Will you join with me? R is equal to 1. Yes, tell me. Substitute here. 1 plus 1, 2 factorial minus 1 factorial. R is equal to 2. So easy, no? Yes. R is equal to 3. When it is easy, it becomes boring. Okay. So let me go for the last two. R is equal to 9. Yes. You have to remember this is R plus 1, then minus R factor. Okay. So this is 10 factorial minus 9 factorial. Good. R is equal to 10. Okay. Now comes the problem. Not the problem, this problem. Okay. You don't think it's a problem. Summation. Summation means what? You have to add everything. So I'm going to add all this. Plus, 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 so on. Plus. If you check all the values here, we'll get a small note. 2 factorial plus 2 factorial minus gets cancelled. Okay. 3 factorial minus 3 factorial cancels. Obviously, 4 factorial here you'll have 4 factorial will get cancelled. Okay, then come here. Minus 10 factorial plus 10 factorial gets cancelled. Here's minus 9 factorial. The term below will have 9 factorial minus 8 factorial, right? So this and this will get cancelled. Ultimately, if you add all these, I will get 11 factorials left out. Minus 1 factorial is. So summation R is equal to 1 to 10. R into RPR is nothing but 11 factorial minus 1 factorial, or you can write it as 11P11 minus 1P1 in any way. Okay, okay, it's not yet over. Let me finish it off. In case if I take summation R is equal to 1 to 50 R into RPR. Yes, can I get the value? Direct final value. Yeah. See, if it is 10, you're getting 11 factorial, which is, this is R plus 1 factorial minus 1 factorial. So this will be 51 factorial minus, see the last one is because of this 1 factorial only. So you'll have it as 1 factorial itself. So this is 51 factorial minus 1 factorial. So this was asked once in the exam like this. Probably it was given algebraically. Algebraic means they will not give number as 50 or 10 or 11 or something like that. Instead, they were giving this as R is equal to 1 to N R into RPR. So what's the value? Yes, N plus 1 factorial minus 1 factorial is always 1 factorial. Okay, so 1 factorial. That's it. Yes, you can please make a note of it. What happens if we have summation instead of R is equal to 1 to 10? If I take R is equal to 3 to 10, what will be your value? 11 factorial minus 3 factorial. How you got 3 factorial? Yes, obviously 3 factorial is right. How you got it? Because we'll be starting from here. See, we'll not be considering these two, right? So this will be 4 factorial minus 3 factorial. Obviously, this 4 factorial, everything will get cancelled. And the last one, 11 factorial will be here. And this one, 3 factorial will be. So now this formula will have 3 factorial as the. So it's not like for everything will have 1 factorial. Okay, so if 3 is given here, the final value here, the last term here will be 3 factorial. So likewise, you can guess summation R is equal to 5 and 15 factorial is given. So this is going to be 16 factorial minus 5 factorial. Okay, so this is what you call as presence of mind in the exam. Okay, so just seeing this term, you should not directly give the answer as 1 factorial. Okay, this small thing you can make a note of it. Yes, please. Should I turn over? Second. Yes, please join. So first question, under combinations. Comparing to permutation, combination will be somewhat easy only, okay. So first question here, in an examination paper, 10 questions are set. Okay, how many hands with Z? Internally happens. For one handshaking to happen, we need to have, okay, no doubt in that. I cannot shake hands along with my own I'm shaking hand with one other person, another person. See, it's clearly given after everyone has shaken hands with everyone else. So I'm not shaking hands with my own hands. I'm giving my hand to another one. So shaking of hands is with two persons. So for one hand shaken, we need to have two persons. Okay. So you need to find n. R is known, which is 2. Okay, for one handshaking, 2 persons. So R is known to be 2. And what's the answer? What's the total number of handshakes given? 66. So the hint here is NC2 is equal to 66. You don't know N. That is total number of persons. You don't know N. For one R, for one handshaken, R is 2. So R value is 2. And the answer is given to be 66. You have to find the value of 66. So you can try this one, else I help you. So this is the hint. You have to solve the value of n. I think n value will be 11. You can check. Okay. Shall I go for the third one? Third one, as the concept we have done, a man has 3 friends. In how many ways can he invite one or more? Once you see this phrase, you have to understand one or more, no or more. You know the formula? No or more. What's the formula? We can refer 2 power n. Okay. See, n1 plus 1, n2 plus 1 is done only when we have groups. Same thing alike. Okay. Here all 3 different friends, right? In case uh, 1 or more, yes, 2 power n minus 1. 2 power n minus 1. Okay. 1 second. So I'm starting with problem number 3. Please join. A man has 3 friends. In how many ways can he invite? It's not be, it's he invite one or more of them to dinner. It's about choosing problem, combination problem. Okay. So I have the words in case, if I have the words no or more, I'll get the formula as 2 power n. In case I have one or more, I'll get the formula 2 power n, then minus 1. Here is given 1 or more. Okay, so what's the value of n? 3 friends. See, you're going to invite 3 friends for your birthday party. Okay, but your dad has given only 100 rupees. So what do you do? We invite only 2 friends. Okay, your dad says this time you are in 12th standard, so no birthday party. Okay, okay, we'll choose one friend who will get you gift. Okay, so this is how it's happening. Either you invite no or more friends, or you invite one or more friends. Sometimes it happens 2 or more friends. Usually will not get that as a question. Here the question is 1 or more friends. So what's the formula? 2 power n minus 1. What is the value of n? 3. So the value is 2 power 3 minus 1. So what's the final value? Once this question was asked in the exam, not with respect to inviting 3 friends, instead you're going for a shopping haul, which means you're going to buy something for your home. Within your budget, the budget will not be mentioned because this is not that type of a practical problem. So you have this budget, you have to buy refrigerator and a washing machine and some grinder. Okay, in how many ways you buy no or more or one or more? The refrigerator cost is not given because not a practical problem. It's not that much practical problem. So refrigerator cost not given. Washing machine cost not given. This grinder cost not given. That budget not given. Nothing is given. In how many ways you can choose one or more? So how many items are there? How many items you are planning to buy? 3. So n is equal to 3. But within your budget, you can buy one or more. Depending on the value, you buy one or more. So the answer is in 7 ways you can choose it. Is it okay? Yes, sir. You can please make a note of it. Let us finish first 3 problems, then we'll go. How you worked out the second one? NC2 is equal to 16. Option will be given in the exam A, B, C, D. Sorry, 66, right? 66. It may be given 10, it may be given 12, it may be given 14, it may be given none of these. Okay. You can just directly try substituting. You can try substituting 10C2 and you can check whether it's 66. Okay. But already you know the answer. This is 12. If you want to do this algebraically, what is NC2? N into n minus 1. You'll have two factors. See, what is the value of r here? 2. So in the numerator, we'll have two factors divided by 2 factorial. This is equal to 66. So this will be n into n minus 1 is equal to 66 into 2, which is 132. If you see the nature of this n and n minus 1, you'll get two consecutive numbers. What do you mean by consecutive? Means next numbers. 4 and 5 are consecutive. What is next to 5? 6. Then 5 and 6 are consecutive. So if you have like 3 consecutive numbers, you can write 7, 8 and 9. See 7, 8, 9. Next numbers will be called as consecutive numbers. So if you find if you check the nature of n and n minus 1, see you have n minus 1, which means you have two consecutive numbers. So you take the value of n in such a way that if you multiply one number less than that, you'll get 132. So if you take 12 and 11, you'll get 132. So what's the value of n? 12. No, ma'am. I'll go step by step only. If you say this way, then n into n minus 1 will be n squared minus n is equal to 132. Okay, so this will be taken as n squared minus n minus 132 equal to 0. You know this factorization method? Okay, so this minus 132 can be written as what? 12 and 11. We have to get minus n. So minus 12 and plus 11. So n minus 12 into n plus 11 is equal to 0. So n value is 12. We need not work so hard and all here. You can make it simple. Either you go for the option, or if you are okay with this type of calculation, then it's fine. Okay, so make it simpler. Okay. What about the first one? A, you got the value of 10 power 6 and 9C5, right? 10C6 and 9C5. Shall I go for the fifth one now? Fourth one, sorry. Fourth one is a different question. Fourth one is a different question. It's a descriptive question, little geometric. N points are in space. Again, you don't know what's the value of n. So that's a question you have to find the value of n. N points are given. No three of which are collinear. What do you mean by collinear? I'll take point A and point B. Okay. A and B will be called as collinear, which means collinear. Linear means that's what line. A and B falls in this line. If I take a point C, yes, C is collinear. I'll take some point D over here, which is not falling in that line AB. So D is not collinear. Okay. Here they say that no three of which are collinear, which means if I take 3 points, it will be like A, B and D. It will not be C. What they say? No three of which are collinear. If you take any 3 points, totally how many points are here? N. If you take any 3 points, you will not find that all 3 falls in a line. Okay, so you will not have, in case, for example, I take some point E, some point F, some point H, some point G. Okay, we will not take A, C, B, will not take. Instead, what we'll take? We'll take A, we'll take B, we'll take G. See, A, B is collinear, but G is not collinear. How many points are not collinear here? No, 3, which means there should be minimum 2 points only collinear. Not more than that is collinear. Now the question is we have to find n. Now the question is if the number of straight lines and triangles with the given points only as vertices. What do you mean by vertices? For example, if I draw a triangle, rectangle. Okay, you'll call this as vertex, right? What is vertex means? The joining of 2 points, two lines. So with the help of the n points given, I tried joining the points so that I draw straight lines and I draw triangles with the given points as vertices, obtained by joining them are equal. Okay, we have to find the value of n. We have worked a similar problem in permutation. If I give you the hint, you will find it easily. Calcutta and America. Can you please turn to that problem? Calcutta and America, Yeah. C is equal to twice of A. So try forming such type of an equation here. Try to recall that problem. Calcutta and America problem. Calcutta and America problem is with respect to the number of arrangements. In how many ways Calcutta can be arranged? In how many ways America can be arranged? So Calcutta is equal to twice of America. We did this there. What happens here? Instead of this Calcutta's arrangement and America's arrangement, we have forming of straight lines and forming of triangles. Okay. So it's about saying equal. So let me have the sign equal. Which and which are equal? See, if you have some x, if you have some y, x is equal to 1. What is given here is number of straight lines and number of triangles. So this side you'll have number of straight lines and this side you'll have number of triangles. See, this is with respect to choosing. For a straight line to be drawn, what equation you can frame here is NC2. The way, see, like we did for handshaking problem. Minimum 2 persons, minimum means exactly we need 2 persons to handshake. Likewise, for forming the straight line, how many points do you need? See, when we draw this line, we actually have so many infinite number of points will be there. But 2 points A and B is enough to draw a line. In case if I take some points C, A and C, I can draw a line, right? So 2 points are necessary for drawing a line. Like this triangle, 3 points are needed. Minimum 3 points you need to have. With the help of 2 points, you cannot draw a triangle. So this is equal to NC3. This is the equation. You have to find the value of n. Can you please try? Please go through once again the full question. Check whether you can able to form this one, can understand. Then go for solving the value of n. Okay. Without solving, directly seeing the nature, you can find the value of n. But try without solving it and check with solving it. Yes, please. So if you just have this relationship between the NCR and NCR n minus r, if you add this NCR, this r, and this NC n minus r, n minus r, what you'll get? N. Okay. So if you add this 2 and 3, you have to get n, which is n takes a value 5. Else, if you don't want to go this way, if you want to solve it, this will be n into n minus 1 divided by 2 factorial 2. I write it directly. And this is n into 3 factors, right? N into n minus 1 into n minus 2. Okay, n minus 2 divided by 3 factorial, which is 3 into 2 into 1. Let me strike off these two. Yes, I can strike it out. It's in the numerator and in the opposite sides. And here I have 2, here I have 3. So this 3 will go to the other side. So 3 is equal to, this is n minus 2. Okay. So n is equal to 2 plus 3, 5. Okay. Anyway, you can find it directly from the relationship or you can try solving it. Anyway, if you find this question in your exam, the answer is going to be 5. So you need not solve this. Okay. Shall I go for the next problem, Tom? Fifth one. Fifth one is also a different problem. Shall I carry on? How many different triangles can be formed by joining the angular points of a decagon? What do you mean by angular points? It's nothing but vertex. Where you will find the angle? Only if you join two lines, right? So this is a right angle or like this. When we talk about the angular points, they are nothing talking about vertex point. Okay. It's about decagon. Decagon is a 10-sided figure. So this is one question. You also have to find the number of diagonals in the decagon. Okay. Instead of going for 10-sided figure, let me go for a 4-sided figure. I'll take a simple one. Okay, let me go for a square. Okay. How many points we need for drawing a square? 1, 2, 3, 4. How many lines can be drawn with the help of 4 points? My question is different now. How many lines can be drawn with the help of 4 points? See, I have point 1, point 2, point 3, point 4. Four dots I have. Like, How many lines I can draw? 1, 2, 3, 4, 5, 6. Can you check? 4C2, right? Why 4C2? Totally 4 number of points given. For drawing a line, you need at least 2 points. So 4C2. What's the value of 4C2? 4 into 3 divided by 2 factorial. So 6 lines. You're getting 6 lines? See, 1, 2, 3, 4, 5, 6. 6 lines. See, these 6 lines are nothing but 4 boundaries and remaining 2 are diagonals. Okay. These 4 are, what do you mean by boundaries? That defines the shape. Boundary is defining the shape. So 4 boundaries and the remaining 2 are diagonals. If I talk about pentagon, you know what is pentagon? You know our recent parliament building is in pentagon shape. Pentagon. Pentagon is 5. Penta means 5. 5-sided figure. So you have 5 boundaries. You can check 1, 2, 3, 4, 5. 5 boundaries. Totally, how many lines can be drawn with the help of 5 points? See, 1 point. Take a different color. 1 point, 2 point, 3 points, 4, 5 points. I have 5 points. Totally, how many lines can be drawn? 5C2. Yes, 5 into 4 divided by 2, which is 2. Totally, 10 points can be drawn. But 5 are the boundaries. Remaining 5 are the diagonals. So among this 10, 5 are boundaries. Let me write it as B. And remaining 5 are diagonals. Okay. Now come for decagon. Decagon means it's a 10-sided figure, which means what? You'll have boundaries, which is 10 lines will be forming the boundaries. And you'll have 10 vertex. So totally how many triangles can be formed? See, I'm talking about lines here. Now they are asking about triangles. Yes, tell me. 10C3. Simple. Make it simple. Don't complicate yourself. For lines, it's 2 points. For triangles, we need a minimum 3 points. So it's 10C3. Yes, value. So you can find the value, right? 10 into 9 into 8 divided by 3 factorial, which is 3 into 2. Can I get the value? So this is 3 times. This is 4 times. I think it's 140. Sorry, 120 triangles can be drawn. So how many triangles can be drawn? 120. Okay. This is first question. Now, how many number of diagonals can be drawn? So now only we checked here. Here, from 4 points, 6 lines can be drawn. 4 are boundaries, remaining 2 are diagonals. From 5 points, 10 lines can be drawn. 5 are boundaries, remaining 5 are diagonals. Okay. So, among the 10 points given, you have to find total number of points lines can be drawn. So, it's 10C2. What is 10C2? 10 into 9 divided by 2 factorial 2, which means you can cancel and you can get the answer as 45 total number of lines can be drawn. Is it okay? In this 45 lines, you will say that 10 lines are the boundaries because it's a 10-sided figure. 10 lines are the boundaries here. And remaining 35 will be diagonals. So, how many number of diagonals can be drawn? 35 diagonals can be drawn. Okay. In case instead of giving decagon, they give as n-sided figure, n boundaries. So, what would be answer? How you get this 10? Because 10-sided figure, it's 10. So, this is n minus. Remaining are diagonals. So, number of diagonals, okay, is equal to, see, this is the value 45, right? So, this is NC2. So, what's the formula? NC2 is equal to n minus number of diagonals. So, if you know the value of n, you can substitute in the formula and you can get it. This was asked once in the exam. So, this is NC2. The total number of lines can be drawn. From this, n will be the number of boundaries. So, let me write it as number of boundaries. From that, you can subtract or from the total number of lines. Let me make it this way. From the total number of lines, I reduce the number of boundaries so that you get number of diagonals. Is it okay? Yes, I can please make a note of it. First problem. Find the number of ways of selecting four letters from the word examination. So far we were discussing like N and R are most of the cases same. For example, with your problem or any number of problem, N and R are same. First time we are having this as a comprehensive problem because you have to understand whether this is a permutation or combination problem first step. And please focus on the wordings given. Selecting, so it's about choosing. In case if your question is about arranging, okay, probably number of ways of choosing four words. If it is given as four words, we have to go for arrange. Here's a simple one. It's a selection problem. So it's a combination problem. Okay. In case it is a permutation problem, I'll deal it later. From the word examination, okay, the problem here is you will find that A is repeated, N is repeated, I is repeated. So many repetitions we get. And moreover, we are not going to select everything. What we are going to do here, we're going to select only four letters. Okay. So let me first segregate with respect to repetition. E is repeated only once, so I take it separately. X is repeated once, I take it separately. A have two times, so A and A. Let me group it. Okay, I have to group it. Then M, I think only once. Then I think two times, so I and I. Okay. Then N, repeated two times. Okay. Then A, already have taken. T, only once. I, already taken. O. Yes, tell me. Totally, how many alphabets are here? 3, 3, 3, 9, 12, 11 alphabets are here. But if we do a small scrutinizing work, I'll find that 1, 2, 3, 4, 5 alone without repetitions. And this complete 6 numbers are repeated. 6 alphabets are repeating twice. Now the problem arises as 3 cases. Because it's given 4 letters, I have to discuss as 3 cases. Case number 1, I'm going to form or I'm going to choose 4 letters so that everybody are different. Every alphabet is different. Okay. Example, which is all different. My case, I'm naming this as all different. Example, like I'm taking E, I, A, O. See, it's all different. It's all different, but what's the problem here is, if I take A, it may be coming 2 times, but what I'm going to do here, I'm going to take only once. If I take O, it's repeating only once, so no problem. If I take T, it's repeating once, no problem. Okay. If I take A, there may be having 2 A's, but I'm going to take only 1 A. So in how many ways you can choose this? Totally have 5 here and you have 3 here. Am I right? Okay. So it's all different. So among the 8, I choose only 4. Please make a note. Among the 8, I choose only 4. Is it okay? How many are totally different alphabets here? E, X, M, T and O are not repeating. But instead A, I and N are repeating. But if I take A, I'm going to take only once. So it looks like all different. Okay. So this is 8C4. This is case 1. If I go for another case, case 2, see, this may not be the option always. For example, I may take it as E, T, A and A. E is appearing only once, no problem. T is repeating or appearing only once, no problem. But when I take A, I'll get 2 times. I may get this option also, this way of choosing. So this is 2 like and 2 alike, which means 2 different and 2 are same. Okay, see, this E and T are different. But when I take A, when I go for choosing A, what I'll do? I take both the A's. See, instead, what I did in the first case is when I take A only once. In this case, what I do here is when I go for choosing A, I take 2 times of A. When I go for choosing I take 2 times of time. Okay, so what happens here is, for this case, 2 like, totally how many alphabets are here? Or let me go for 2 alike. Okay, yes, tell me, how many are here? I can choose from AA or II or NN. I have only 3 options. So from this 3, I will take 1. If I take A, which means I'm taking two alphabets. If I take I, which means I'm taking two alphabets. So 3C1, it's not 3C2, it's 3C1. Okay. And for this and I'll take multiplication. You remember? And means multiplication. Now other two are different. Okay, so other two are different. So probably if I have taken A and A, now the remaining left out is 5 plus 2. Am I right? Am I right? This 5 all different. Because I have taken A and A, what is remaining? I and N are remaining. So if I take I, I'll take only one I. If I take N, I'll take only N. Okay, so this is 7C2. Why this 7? I'll place a star mark. Why this 7? Because 5 all different and one I have already chosen with respect to same and I and N repeated. So it's 2. So it's 7C2. So this 7 is because 5 plus 2 and this 2 is because this E and T should be different. Or I can take this example also. Instead of taking E and T, I can take this as E, I, A. Please try to understand. This A and A repeated. See, I actually is repeated twice, but I take only one I while choosing. Okay. So this is case 2. Now case 3. Case 3. Example. I take in such a way it is I, A. So we get like this, right? Or I may take as N, I. This is not arrangement, it's combination. I'm not writing in an arrangement way. Probably I can take this as a basket. In a basket, I'm dropping I. This is a basket, I'm dropping N, I. So what happens here? I will not consider this 5 different alphabets at all. Instead, among these 3, I'll consider any 2. So this is 3C2. If I consider 2, what happens? It comes in pairs. So it will become 4. So this is 2 sets alike. What's the heading? 2 sets alike. Probably I can have 2 different and 2 alike. 2 different and 2 alike. Is it okay? You please go through. If you want, I'll explain it again. See, let me take out this problem again. You can please join with me. Find the number of ways of selecting 4 letters. So R is equal to 4. From the word examination. Okay. 3 cases may arise. Case 1. What is case 1? All different. Okay. Second case, 2 different and I think this one, right? 2 different and 2 alike. Alike means same or similar or whatever it is. And case 3, all same. Huh? There is 2 same and other 2 also same. 2 same, 2 alike and other 2 also alike. For example, this is all different. See what are the different alphabets we have? X, E, X. Can you help me out? E, X, M, T and O. The set A is repeating twice, I is repeated twice and N is repeated twice. Okay. See, first cases all different. So for example, I can take it here as some M, O, I, N. Okay. So how many different alphabets you have? E, X, M, T, O. Along with that, single A, single I and single M. So how many I have? 1, 2, 3, 4, 5, 6, 7, 8. See, this is 5 and this is 3. So 8. So from this 8, I am choosing 4 because any one is taken only once. Even though if I choose A, it's taken only once. Okay. So this is 8C4. Hope it is okay. Second case, 2 different and 2 alike. Can you give an example? N, X, O, N. Okay. Or let me take it as N, A, I, O. See, N we have two times. A we have two times. I we have two times. Oh, sorry, it's two different and two alike. Sorry. It's N, okay, two alike. So N and N. Yeah, I took it correctly only now. N next O N. Okay, so two different and two alike. And another one example, probably I'll take N two times, I once, and O once. See, two alike and two different. Okay, so how many different options we have? So for all different, I have E, X, M, T, and O. Okay, for two alike, I can take A, I, N, N. In this, you go for choosing two alike first, because among this three combination, if I choose one, it is getting, actually choosing one means you're choosing two alphabets. So for this two alike, it is 3C1. For example, if I have chosen this combination N and N means I already have chosen this one. Already I have 5 different alphabets. Among this 5, I can take A and I, another 2 alphabets put together. So this will become 7C2. Why it's 2? Because I have to take only 2 here. Here I have taken 1, but this 1 means it's actually 2 and this 2. So you know why this is 7? 7 different alphabets. So 7 and 1 is already chosen. So 2 will be left out. From that 2, I'll get one choice or 2 choices, both the choices. So I'll get 2. Okay. And case 3, example, yes, 2 alike and other 2 alike, which means I can take it from AA or II or NN. Okay. So I can have it as AIIA, or I can have it as NINIA, or okay. So among these 3, if I choose 2, which means 4 will be selected. So this is 3C. Is it okay? Hope it is okay. Okay. Online. Shall I continue? Shall I go for the next problem? Hope it is okay. Yeah. Next problem is quite simple. Directly I'll go for the problem. Number of parallelograms that can be formed from a set of 4 parallel lines intersecting another set of 3 parallel lines. So it's a little geometric. So what do you mean by parallelogram? We'll have parallel lines. Opposite lines will be parallel and equal. Okay. So probably if you take this line and this line, it will be parallel. And if you take this line and this line, it will be parallel. Okay. Now, just think in this way. You have this line, okay, and you have this line. Definitely these two will be intersecting at this point. Am I right? So you have one set of parallel line and another set of parallel line, and these parallel lines are taken in such a way that they will intersect. Now read the question. Join with me. The number of parallels that can be formed from a set of 4 parallel lines. So I have a set which consists of 4 parallel lines. Intersecting. Obviously, when you intersect only, you'll get a polygon. Polygon means bounded figure. Another set of 3 parallel lines. So I have another set of 3 parallel lines. Okay. So if you take this line and this line, see, it will intersect. Because it's given, it will intersect. For a parallelogram, we need to have how many lines? 4 lines in total. But I'm not directly going to take this as 4 lines. Instead, I'm going to take as 2 lines and 2 lines. This 2 lines, I can take it from set A. And this 2 lines, I can take it from set B. So in how many ways it can be formed? How many are here? Totally 4. From this 4, let me select 2. And so multiplication. From this 3, I can select 2. So the answer is 4C2 into 3C2. Okay. Because it's given 4 parallel lines, I'm taking 4. I'm not taking on my own. See, it's given 4 parallel lines. Another set is given 3 lines. That's why I'm taking 3C2. Instead, it's given 7 parallel lines. We'll have 7C2. So you have to try from the question. Okay. Yes, you can please make a note of it. Problem number 3. Here's a boat screw. Consists of 8 men in total. There's a restriction here. 3 of whom can row only on one side and 2 only on the other side. So you know this boat race and all in Kerala, they take place for like a some boat festival. Like how many persons are in total? Eight. Okay. So eight means equally they split into halves. Okay. It's like one, two, three, four. One, two, three, four. Okay. Thus, the restriction says three of whom can row only on one side. They are not mentioned left side or right side, so let me have it as any one side. So three persons I fix over here. One, two, and three. Two only on the other side. So some four and five. So these five persons are restricted. Now what happens here is I have from this five, if I remove it, I have only three persons left out. I have to arrange these three persons, not actually arrangement. This is a combination problem. I have to fix it. Tell me, if these three persons are X, Y, and Z, either you can fix X over here, Y, Z over here, or you can fix Y over here, X and Z over here. So you have different options. Okay. Actually, we work this as a combination problem, but it's asked as a permutation problem. Then we finish it as permutation because we know this NCR is equal to NPR divided by R factorial. So we work out NCR first, then we multiply by R factorial, which becomes R factorial into NCR, you will get NPR. Yes, tell me, how many are in total? 8. From this, we group 5 separately and this 3 separately. Okay. We are not going to worry about this 5 because already they are fixed. We are going to worry about this 3 only. From this 3, see, we already know that 3C1 is equal to 3C2. Yes. If this R values are added, if you get the N value, then it's going to be equal. Okay. So 3C1 and 3C2 are same. So either you can take 3C1 or 3C2. You may ask why 3C1 and why 3C2. See, if I take this places from the 3, I'm going to fix 2 people. So it's 3C2 you can take. See, already in combination, you know, if I form a group, the left out will be formed a group automatically. If I choose Y and Z here, automatically where are you going to place X on the other side? If I choose here Y, automatically X and Z will be forming on the other side. So 3C1 or 3C2 is both same. So what I have done here is I have now fixed the places. What I have to do here is I have to arrange it. See, this is a place where 4 team member will be there and this is a place where 4 team member will be here. So this can be done in 4 factorial into 4 factorial ways. You agree with me? Why 4 factorial? 4 places, 4 different ways. Okay. Why this 4 factorial? This is probably can name this is for left hand side. This is for right hand side. So your answer is 3C1 into 4 factorial into 4 factorial. Or you can take 3C2 into 4 factorial into 4 factorial. So why is this 4 factorial part? It's a arrangement problem. It's a permutation problem. If it is a combination problem, it's just 3C1 or 3C2 is the answer. Because you are arranging it, left hand side and right hand side, internally you are arranging it, you have to multiply by 4 factors. Is it okay? So, from the first problem, please make a note. Instead of given as selection, instead it's given as arrangement means or some type of word used for permutation means you have to multiply with 4 factorial for all your answers. Because we are done as a combination problem. See, only C is used. Okay. So if you multiply everything by 4 factorial, it becomes a permutation problem. So instead of 4 letters, they may ask us for 4 letter word, which means arrangement. Okay. Can please make a note. So you have to see the answer is simple. Simple. You're working as combination problem and multiply by 4 factorial. Okay. Shall I take over? Next problem. Problem number 4. If all the permutations of the letters of the word chalk are written in a dictionary, What is the rank of this word? So you know how to refer a dictionary. So it goes with alphabetical order, right? A, then B, then C, then D, up to Z. If you go for A, the set of A papers, you will find that it goes with AA, then AB, then AC. Again, if you go for AA, you will find that A, then AAB. See, this is how you refer the dictionary. Here the words given, here the word given is chalk. And what are the different alphabets we have? C, H, A, L, and K. And you're finding all the different words can be formed because permutation, arrangement, we are talking about arrangement. We are finding all the different words can be formed with the word chalk, and they are listed in the dictionary. Which word is this chalk appearing for? Which means what is the rank of this word? You turn the pages. You'll get C first. See, I want this chalk in the dictionary. Okay. You'll find C first. No. You will find starting with A. Then you will find C. Okay. After that, you will find H or L or K. So what's the alphabetical order? First A, then C, then which comes? H comes, then K, L, M. So K comes, then L comes. Am I right? Okay. If I refer the dictionary, I'll get first set completely falling with A. I don't want the complete set. Okay. So in how many ways I can find the different set? If I fix the first alphabet with A, the remaining four alphabets can be arranged in 4 factorial ways. Am I right? So this 24 words, I don't want all the 24 words because I want the word chalk. Next, I go refer the dictionary. What's the arrangement here? C. Okay. You know that after C, what will appear? H will not appear for me because I want H, but H will not appear. But instead, A only will be appearing. So this A. But again, I don't want CA. I want CH. So obviously, all the remaining is not needed. So this can be done in 3 factorial ways. Why 3 factorial? C is fixed, A is fixed, remaining only 3 alphabets need to be fixed. So this 3 factorial, which is 6, I don't want all the 6 alphabets, 6 combinations, 6 words. So I leave it. Then I'll go for the third set. Already has C, I fix it. I leave out all the A combinations. Next, what combination I'll get? H. Next, what combination I'll get? A. Beautiful. But I want L next. But what is in order? K. Okay. So I'll get K, then only L. This is all fixed, which is one word. Again, I don't want this word. Then I'll go for the next combination. C will be fixed. H will be fixed. A will be fixed. Obviously, I have taken already K and I left out that word. Now, in the order, it will appear as L, then K. Okay, I'll place a star mark. Actually, this word will appear only after all these sets appear. So, in how many ways I can do this one? In one way. Why it is one? C fixed, H fixed, A fixed, L and K all are fixed. So, one. So, after escaping from all these 31 words, this 32nd word is my required word chalk in the dictionary. So, the answer is 32. See, what's the question? What is the rank of this word? Rank means in which place this word appears. So, in which place it appears? As a 32nd word. So, probably your question may be, after how many words chalk appears? What's the answer? 31. After how many words? After 31 words, you get this word. So, if the question is what is the rank of this word, your answer will be 32. If your question is after how many words chalk appears, your answer will be 31. So, I'll place a star mark. You can take it as a note. The question may be after how many words chalk appears. Chalk appears. So, your answer here is going to be not 32, 31. In this question, what is the rank of this word? So, it's 32. Yes, can you please make a note of it? Next problem, fifth one. It's a easy problem. There is a family having 4 brothers and 3 sisters. It's to be arranged for a photograph in a one row. Okay, it's a row normal problem. In how many ways can they be seated? Now there is a restriction. All the sisters sit together. Okay. So we know this Vecchior problem. We make blue and red together as one position. So likewise, if you work out this problem, there are four brothers. So we'll take four different positions for them and three sisters. All the sisters will sit together only. So three sisters can be taken for one position. So how many positions we need? Five positions. So five, not P, five, 5P5 because it's a photograph arrangement. 5P5. So this can be done in 5 factorial way. But these three sisters can be internally arranged. Sister 1, sister 2, sister 3. Or so usually we do this like sister 1, sister 2, sister 3. Or you can make sister 1 sit in the middle. Sister 2 and sister 3. So there's an internal arrangement which can be done in 3 factorial ways. Is it okay? Now we come for no sisters, two sisters sit together. You remember this plus and minus sign problem? We have 6 plus signs and 4 minus signs, where two negative signs not together. So same like no two sisters sit together, which means I make the brothers to arrange first. So how many brothers here? 4 brothers for 4 positions. Okay. So which can be arranged in 4 factorial ways. Now I have to make the sisters to be arranged. I can make it sit here, 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 and here. Actually, there are 3 sisters, but I'm getting 1, 2, 3, 4, 5 different positions, which can be done in 5P 3 ways. Yes, now please make a note of it. Next, I have 2 more problems. Sixth one. The Supreme Court has given a 6-3 decision upholding a lower court. The number of ways it can give majority decision. So you know this appealing of cases. So when there is a case going in high court, proceedings going in high court or some district court, you can go to the higher court for appealing. Okay. And when you go for appeal, actually 3 cases will happen. Either they'll not directly go for judgment at all. When an appeal is filed, either the court will be saying, okay, we'll take the appeal. Else the court will be saying, will not take the appeal. It's rejected. Appeal case is rejected. Before going to proceeding itself, they'll reject the case. Else they'll take up the case, then they'll go for proceeding. And one more case where they'll be giving an order where the lower court itself will go for another revision of judgment. So usually these 3 things happens. So either the appeal case may be accepted or rejected, or an order will be passed where the lower court itself will go for another one revision. Okay. So this type of a problem here, the Supreme Court has given the decision saying that 6-3, which means it's called as bench court. You know bench court? 2 bench court, 3 bench court, 5 bench court, where 5 judges will be present. Here it's totally 6-3 means 6 judges has given in favor of something, 3 against. Or 6 has given in against, 3 in favor. Okay. So some cases going in the lower court, and this has been appealed to the Supreme Court, and the judgment has now come how many? 6-3, and it has been reversed, which means what? Probably it might be given in favor of that person. Now it has gone to the Supreme Court and reversed. Okay. Now the question is, in how many number of ways it can give a majority decision? What do you mean by majority? It's obviously an odd number, 9. Why it is 9? Because totally 6-3. 6 in one side and another 3 in another side. So totally how many judges are here? It's a 9 bench court. Okay. So from this 9, in how many different ways you can give the judgment? Giving a majority decision. What do you mean by majority? More number of persons should be present. Okay. So shall I go for this option? 9 all together, 0 other side. Else 8 all together, remaining 1 on the other side. This is majority. One judge says this is wrong. Another all 8 says it's right, which means it's right. Okay. Or I can go for 7 right, 2 wrong means what? Another side. Okay. Fourth one, 6 and 3. And another one, 5 and 4. Shall I go for 4 and 5? No, I cannot go for this option because 4 becomes minority. So I cannot go for. So all the different options available are these 5 cases. So if the first case is taken, see, I'm not going to consider this case. I'm going to consider only this case. So if I go for this one, among the 9, all the 9 are said okay. So 9C9. Okay. See, not and, it's or. Or means what? Addition. So you have to add. Many of them will get confused with and or. Here is not and. This may be the case, or this may be the case, or this may be the case. So it's or, so it's addition. Okay. So next is from the 9, 8 has given together. Or third case. From the 9, 7 has given together. Or fourth case. From the 9, 6 together. And last case, from the 9, 5 together. So if you add all these values, you get the total number of. So option is given A, B, C and D. You can please check. Let me finish off the seventh one also. Hope it is okay. Sixth one. We'll go for the seventh one. 5 bulbs, of which 3 are defective, are to be tried in 2 bulb points in a dark room. Okay. In how many trials the room can be lighted? It's a beautiful problem. You will get the same problem in probability also. Instead of in how many trials, it will be given what's the probability of lighting the room. Okay. Yes, try to understand the problem. How many bulbs you have in your hand? 5. How many plug points are there? Bulb points? 2. It's a dark room, which means it's already dark. So just imagine there is a room. Okay. There is an entrance here. You have the switchboards here. Okay. You have 2 bulbs, which means 2 bulb points. One over here and one over here, for example. Okay. How many bulbs you have? 5 bulbs. In how many ways or in how many tries the room can be lighted? So it happens like you try all the switches. If you have like this bulb switch and tube light switches, and you have this plug point switches, you have the fan switches, you try everything. At last only it will blow. Maybe not at your home. You might have gone some halls, some wedding halls. You try all the tuck, 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 tuck. So this will happen. So now to check, the problem is to be lighted. Okay, what you can do? The problem now here is 3 are defective in this. Already have 5 bulbs and there are 3 defective bulbs and there are 2 bulbs which are good. 3 are defective, 2 bulbs which are good. So you have to fix here and try whether the room gets lighted. Okay. You know the switchgear problem, together and separated. First, what we do is we work out for together, then we work out for separated. Likewise, what we hear is in total ways we can make all the trial is from the 5 bulbs, we can make it for 2 bulb points. This is the total number of ways you can do it. My question is for lightening the room. I go for taking all the defective bulbs and where you will not find the light. So this is with respect to defective bulbs you work. How many defective bulbs are totally together? 3. In any way you can try with respect to taking 2. You will get only dark room. Am I right? For the room to be lighted, 1 good bulb is enough for the room to be lighted. So with respect to non-defective bulb, I can make it as 5C2 minus 3C2. Am I right? What is this 5C2? Total number of ways where the room will be lighted, where the room will be dark. And this 3C2 is where the room will be dark only because all the 3 are defective and I am choosing 2. And this will be total number of ways the rooms can be lighted. 5C2 minus 3C2. This is often repeated by the exam. This 5C2 is total and this 3C2 is for maintaining the dark room. For lightening, it should be subtracted, removed, subtracted. Yes, sir. So that's all on permutation and combination. You can make a note of it. In the next class, we'll go over a different topic. Okay. Thank you.